Hello and welcome to the second of a series of 3 for GCSE higher tier maths exams taken on November 2019. So this is paper 2, it's a calculator paper. I'm going to recommend here the GCSE class whiz, which comes in 2 flavours, an A-level version and a GCSE version. If you can, get the A-level version. The GCSE version is here. Okay, so this is a calculator I'm going to base the solutions off. Casio, I love. Okay, other calculators are just as valid, but I do think Casio, in my opinion, is probably the best. I'll talk through the questions with you step by step. Sometimes I'll show you more than one method. If you're using a different method to me, but still generating the correct answer, then you can probably assume your method is correct because there's numerous methods for each question. If in doubt or you're not sure if you've got your method right or you just got the answer correct by a sheer luck or a fluke, please do ask me or ask your teacher. That's enough from me. Let's get straight to it now. Let's have a look together at question number 1. Question 1, we've got a table showing some information about the weights of 50 potatoes. So weight from 10 to 20 grams, frequency 6, and so on. And over here, a vet has drawn a frequency polygon for the information in this table. It's not fully correct. What you need to do is write down 2 things that are wrong with this frequency polygon. Pause the video and have a think yourself what's wrong. Press play when you think you've got it cracked to see if we agree. So, what 2 things or more are wrong? Well, what you could say is actually any 2 of the following. So, one thing you could say is a point 15 and 6, because you always plot from the midpoints. So this one here should be at 15 and 6. But actually, that point here is too high. That's 15, 8. So the first one's been misplot. Another thing you could have said is the y-axis isn't labelled. What it should say, going down the y-axis, is frequency. So it should say frequency going down here, but it doesn't. So that really is a mistake. The third thing you could say is the line connecting the first and last points shouldn't be there. So from here to there, that line doesn't really need to go there at all. What it should be is not there. So this from there to there shouldn't really exist. Should look more like it does now. We've not got the line quite covering the black. So yeah, it should look something a bit like this. So there's 3 points. Any 2 of those 3 gets you full marks. Question 2, we've got a length of a pencil, which is 128 millimeters, correct to the nearest millimeter. Complete the error interval for the length of a pencil. So it's been rounded to the nearest millimeter. So it's not going up in 0.1 of a millimeter or 10 millimeters, it's going up in steps of millimeters. So imagine the 1 millimeter times table. 1, 2, 3, 4, 5. Keep going, you'd eventually get to 128. So just think of millimeters are surrounding 128. So around 128, you've got below it 126, 127, above 129, 130, 131, and so on forever. But it's actually 128 is the closest millimeter. So 128 is what the number before it was rounded must have been closer to than 127 and 129. So the smallest it could have been before it was rounded up to 128 would have been down here at 127.5. That's the smallest it could have been, but would still have rounded up to 128. So it could be 127.5, it's allowed to be equal to that. Any lower though, it wouldn't have rounded to 128. On the higher end, the absolute maximum limit is halfway between 128 and 129. So the cutoff here is 128.5, and that's the upper bound. You might be thinking, but wouldn't that round up to 129? Yes, it would, which is why we have this inequality symbol here, saying that it absolutely must be less than 128.5. Could be as close to it as you want, but can't actually quite touch. So the boundaries are 127.5 up to 128.5. Those are the 2 values we put in onto the answer line. 1 each, 1 mark. 2 marks in total. Question 3. Tom and Adam have a total of 240 stamps. The ratio of Tom stamps to the number of Adam stamps is 3 to 7. I'm going to put this in blue, and in red, I'm going to put the ratio of Tom stamps to Adam stamps. After Tom's bought some stamps from Adam, it changes to being 3 to 5. So the question is, how many stamps does Tom buy from Adam to make the ratio change from 3 to 7 to 3 to 5? So what we can do here is just think of these ratios separately there's always going to be 240 stamps in total. So let's have a look at a bit more depth. So before, the ratio was 3 to 7, so let's fill that one in now. So Tom had 3 to every 7 Adam had. That gives a total of 10. But of course, we are told at the start there's 240 stamps in total. So those 10 lots of stamps, 3 plus 7 makes 10, must equal or represent 240 stamps in total. So if 10 parts is equal to 240, each one lot or each one part must be worth 24. Another way of saying the same thing is to go from 10 to 240, we need to multiply by 24. And if we multiply this side by 24, we need to do the same to the other numbers too. So now, probably a good chance to use your calculator really. This is the first question I'd recommend you use your calculator on. So the first one, we've got 3 times 24. That gives us 72. Oops, I'll change it to a blue colour. And then 7 times 24, you should see, gives us 168. Afterwards though, after Tom buys some stamps from Adam, the ratio changes to 3 to 5. So in the after table, Tom then has 3 lots to Adam's 5. 3 lots plus 5 lots is 8 lots. But of course these 8 lots, again, needs to relate to this 240. So how do we go from 8 up to 240? Well, sort of in the same way really. We need to just be thinking what we need to multiply the 8 by to get to 240, and the answer to that is we're going to multiply by 30. You could work this out by doing 240 divided by 8. So you need to multiply by 30. And the same way as we did before, if we multiply one number by a certain amount, we multiply the others by that same amount. So Tom must have 3 times 30, which is 90 stamps. Adam must have 5 times 30, which is 150. So returning to the actual question, how many stamps does Tom buy from Adam? Well, Tom went from having 72 stamps to having 90. So how many extra he's gained must be how many extra he bought from Adam. So the difference between 72 and 90, we can do by just calculating 90 subtract 72, which gives us 18 stamps. So the answer is he must have bought from Adam 18 stamps. Question 4. Each person in a fitness club is going to get a free gift. Lucky them. So Stan's going to order these gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him the gift they would like. So you've got sports bag, gym towels, headphones, vouchers, etc. So that's a sample of 50 people. But actually, in this particular fitness club, there isn't 50 people, there's a total of 700 people. Work out how many sports bags Stan should order. So we're going to use this here, which is for 50 people, to make an estimate. So how many sports bags should he order for 700 people? Well, for 50 people, the sports bags, 17 out of 50 say they'd like a sports bag. So for sports bags, the proportion of people wanting a sports bag is 17 out of 50. So we want that fraction of this 700 people. So 17 fiftieths times 700. We can do this now. So 17 over 50 multiplied by the 700 people gives us a total of 238. Another way you could think of this is for 50 people. This is for 700. So how do we scale up from 50 to 700? Well, 700 is 50 times 14. So another way you could think of it is just multiply all these values by 14. If you double check it, 17 times 14 would get you that as well. So either thinking of it as a fraction of an amount or scaling up, you should get 238. Now for part 2, it says to write down any assumptions you made and explain how this could affect your answer. Well, what I've assumed here is this sample represents a typical grouping of people that go to the sports club. In technical language, we assume that the sample is representative. So we could put any one of these two bullet points worded as you'd like. So one thing to say is the sample is random and is representative of the whole fitness club. That's what we'd have to assume for this estimate to be any use. If it weren't the case, how would that affect the answer? Well, it would affect the answer by being a different number needed. So for example, you'd also have to assume that no new members join in between ordering the sports bag and delivery of them. Otherwise, there wouldn't be enough. So that's the assumptions which you'd actually have to make. In terms of it affecting the answer, what I'd also suggest we have to do is, based off whichever point you make, this point or that, I'd put something along as well, just simply saying, otherwise, my answer, the estimate from part A, may not be very accurate. You can't say the estimate's going to be too high or too low. All you could say is it would make your estimate not very good. So rather than say it makes your estimate too high or too low, hedge your bets and just say my estimate wouldn't be very accurate then. Question 5. I could tell you the answer to this in just seconds, but I want to try and explain this to you a bit better. So 6 graphs, which one is y equals x cubed, which one is y equals 1 over x. So I want to explain this in a bit of a deeper way. So certain graphs have certain characteristic shapes. So A, this is called a parabola. That's going to be a quadratic graph. So A is quadratic. So highest power is something to do with x squared. So the flavour of that one is it's a quadratic. So this is a cubic, that's not x squared, so it's not going to be A. B, if it's got a shape that goes up, comes down, then back up again, very much like F, goes up, levels out, then back up again, these are called cubic graphs, where the highest power is x cubed. F is cubic as well, highest power is x cubed. So for part A, it's going to be either B or F. So how do you know which one it is? I'm going to explain that in just a moment. So C, looking at C, this one here is called a reciprocal graph, as is D. So what's the difference between C and D? Well, C is reciprocal, that's the wrong colour. C is a reciprocal graph. But because here, when x is positive, y is negative, and when x is negative, y is positive, that's going to be a graph of a type y equals minus something, maybe minus 1 over x. Whereas down here for D, that's again reciprocal, and it's going to be like something similar to y equals 1 over x. So suppose, yeah, you could say that therefore B is graph D. And E, finally, E is linear. This is something like y equals mx plus c. So by process of elimination, for A, it's going to be either B or F. So it's going to be F. I'm going to explain to you why. It's F because it's just simply y equals x cubed on its own. Over here, that might be something like, say, minus 2. I don't know, so definitely where x is negative. But if you were to do minus 2 cubed on your calculator, be careful as you do it, put in brackets minus 2 and then cube that. You'd get that it's a negative, whereas up here, it's a positive value. So that can't be the case. So it's got to be x cubed. Now, I'm going to show you a hack of how you could also think of these. Your calculator has a table function built in if you've got a Casio. So there's another option. What you could do is this. Press menu and scroll till you get to table, then press 3. F of x is the first function. So we can pick f of x to be like y. Think of it as y equals. This one's x cubed. If I press alpha and then the right bracket, I can get an x and press to cube it. G of x is a different function. I've got 2 different graphs here, so yeah, I can use g to be y equals 1 over x. So here, I'm going to press 1 over x. So alpha, right bracket. Now these graphs have negative x's and positive x's. So let's go, I don't know, from minus 5 to 5 in a step of 1. Then f of x, when x is negative, f of x is y is very negative. And if you just look at f of x here, when it's 0, it's 0, which is very much like this one. And then only when x goes positive does y go positive with increasing speed. 1, 8, 27, 64, 1, 2, 5. So it's going up really fast. So that looks like graph F. It doesn't follow the same numbers you'd expect for graph B. For B, you'd expect some where x is negative for y to be positive, and that doesn't happen because the calculator table doesn't show that. And for g of x, if you look here, just scroll back up, when x is negative 5, g of x is negative, but not very big. As you get closer and closer to 0, the value goes up, and eventually when you get to 0, it breaks. So you can't have it where x is 0, just like you can't for d. These graphs don't touch where x is 0, so that's a big clue that it's d. And as well, if you look at this one here on the calculator, when x is negative, y is negative, negatives and negatives, and then when x changes to being positive, the y is also positive. So that shows you that it has to be d rather than c. That was a bit of a quick tour using the table function on your calculator, but it's worth exploring. You can get a lot out of it. The quick answer, A is graph F, B is graph D. Question 6. The nth term of a sequence is 2n squared minus 1. Then another one is 40 minus n squared. Show that there's only one number that is in both sequences. What I'm suggesting here, we do these, compare one sequence to another, and work out some numbers in both sequences. So red and blue. Let's work out what each would be. So when n is 1, what's 2n squared minus 1 going to be? Same for 2, 3, 4, and 5. I'll show you after as well how you can do this using the table function on the calculator. So when n is 1, 2n squared minus 1, we can work out the slow way. I'll show you the quick way in a moment. So 2 times 1 squared, then it's minus 1, isn't it? Yeah. So your first value is just 1. If I change to what's in the brackets now to a 2, 2 times 2 squared minus 1, let's toggle back, change it to a 2, that gives me 7. When n is 3, I get 17. When n is 4, it's tedious but not hard. N is 4, we get 31. And finally, when n is 5, get 49. Over here, same idea. I'll do this a bit quicker. When n is 1, 40 minus n squared, that will work out to be 39. When n is 2, should think that's 36. When n is 3, that'll give you a value of 31. When n is 4, 40 minus 4 squared is 24. And the last one, when n is 5, 40 take away 5 squared, 40 take away 25 is 15. So we need to show that there's only one number in both sequences. So which number occurs in both lists? If no number was the same in both lists, by the way, you go to n is 6, 7, 8, and so on, until you did find a number in both. But hopefully you can see here, 31 appears in both lists. 31 is the only number that's in both sequences. After 31, this is going to go higher, and these numbers are going lower, so they're never going to be the same again because they're going in different directions. So you show the working, you show that 31 is in each, and then say, therefore, only 31 is in both sequences. So you need to say it's only 31 in both. If you really want to impress the examiner, you could then say the other sequence is going up, the other's going down, so there won't be any other number in the future that's the same. I've checked the mark scheme though, you don't actually have to go that far with it. You just say only 31 is in both sequences, and that's actually fine to get full marks for that one. Very briefly, just to show you how to do this on the calculator, what you could do is press menu and then scroll to table, option 3. F of x just means whatever you want it to be. So ours, first of all, is 2n squared minus 1. So press 2. We can't get an n, so we have to settle for an x. So alpha x squared minus 1. Press equals, and if you want another function, which we do, we type this in for the next one. So we're going to type 40 minus x squared, because like I said, we can't get an n. So alpha, right bracket, squared. So yeah, I want to start at n being 1 up to being n being 5, going up in steps of 1. So press equals, and it gives you the table for you. So if you look here, the first sequence, 1, 7, 17, 31, and so on, and the other one, look, they have 31, exactly the same numbers. The table function on the calculator, can't stress it enough, it's magic when you know how to use it properly. So do bear that in mind, it's well worth a play. Question 7. Work out 3.42 times 10 to the minus 7 divided by 7.5 times 10 to the minus 6. Give your answer in standard form. If I didn't mention I love the class whiz, I'll mention now I love the class whiz, because you just type this in exactly as it appears on your calculator. So, bracket, so type a bracket, 3.42 times 10 to the power minus 7, close off your brackets, divide, then brackets, 7.5, oops, missed the 0.5, silly me, times 10 to the power minus 6. Close brackets, press equals, and we have this here as an answer, 57 over 1250. That is not in standard form. Did I mention love the calculator? Well, if I didn't mention love the class whiz, I'm going to mention again, I love it, because you can get this into standard form by using the calculator. I'm hoping you'd know, though, that the answer should be 4.56 times 10 to the minus 2 when you get to that stage. So I'm just going to write it down. It's 4.56 times 10 to the minus 2. Why is it a minus 2? It's because there's 2 leading zeros before the first non-zero number. That's why it's a minus 2. So that's the answer. But if you want it to be even lazier or even more calculator savvy, what you could do at this stage is press menu, whoops, shift menu, I misremembered, go to number format, option 3, and standard form is number 2, psi. Psi just stands for scientific, because standard form is a scientific way of writing numbers. So press 2. 0 to 9 means how many significant figures you want. Here we only had 1, 2, 3 numbers, so you can type 3, and then press equals again, and then it comes out, if you press S arrow D, 4.56 times 10 to the minus 2. It tells you how to do it. If you want to go back to the normal function on your calculator, again you press Shift, Menu, Number Format option 3. To go back to normal, you can probably guess it's 3 for normal. And for some bizarre reason, option 2, not option 1, is best. So that's another way you can get your calculator to do the legwork for you. Final answer, 4.56 times 10 to the minus 2. Question 8. Number of days that it will take to build a house is given by this formula. D is 720 divided by n, where n is the number of workers used each day. So we've got Ali's company that takes 40 days to build a house, and as well, it says here, Haley also has a company that will take 30 days to build a house. Haley's company will have to use more workers because she's wanting it done quicker, so it stands to reason she'd need more workers. But how many more does she need? So here we're just going to make a comparison between Ali's and Haley's. So Ali's company is going to take 40 days. It says D is a number of days. So D for Ali is 40, whereas D for Haley is 30. So for Ali, we've got that 40 days equals 720 divided by n. So we need to rearrange this to find what n is. So there's a few different ways you could do it, really. What I'd suggest we do is to just multiply both sides by n, to get that n from being on the bottom of a fraction. So we need to have 40n equals 720. Then to get 1n, just divide both sides by 40. Therefore, you should get that Ali needs 18 people. So always use your calculator to suggest. So 720 divided by 40 gives 18. So Ali needs 18 workers. So we can put for Ali that n is 18. We now use the same formula for Haley, but only Haley's using 30, needs it to be done in 30 days. So same formula, but using D as 30 for Haley now. So we need 30 to equal 720 divided by how many workers n Haley needs. So in the same way as we rearrange this equation, we can multiply both sides by n to get 30n equals 720. Then finally, the required value of n for Haley, we can divide both sides by 30. So n for Haley is 720 divided by 30. And again, don't be arrogant, just use your calculator, take your time. 720 divided by 30 gives us 24. So n equals 24. So return to the actual question, what it's asking us. Haley's company will have to use more workers each day than Ali's. How many more? Well, Ali needs 18 people, she needs 24. The difference is the bigger one take away the smaller one. 24 minus 18 is a difference of 6. So in other words, Haley needs an extra 6 workers to complete her job when she wants it doing by. So that's our final answer, 6 more people. Question 9, we've got a cube and cuboid. We're told the total surface area of the cube is equal to the total surface area of the cuboid. So let's start with this bit. So the front of it, I'm going to colour yellow, the side green, the top blue. So for a cuboid, we've got 6 faces to work out the total surface area. So for this cuboid, this is the calculation for the total surface area. So I'll explain where these numbers come from. So 6 times 8, that's the front. But because you've got the front, you'll also have the back. 18 times 6 is for the right-hand side, and of course the left-hand side will be the same. That's why we multiply by 2 as well, just like we multiplied by 2 for the front and the back. And the same here, that's the top, 18 long and 8 wide, but I have to times that by 2 because we've also got the bottom, which will be the same. So just make this really clear. Front and back is that, left and right is this, top and bottom is the 2 multiplied by 18 times 8. So we can work out the total surface area by performing this calculation. So let's do that now. So we're going to have 2 lots of 6 times 8, then 2 lots of 18 times 6, and finally plus 2 lots of 18 multiplied by 8, close brackets, we get there 600. So the surface area of a cuboid must be 600 centimetres squared. And we're told that we've got equal surface areas. So this surface area here is 600 cm squared as well, because it's got to be the same. Okay, so we worked out that this one is 600 cm squared. And because these are the same, that's got to be 600. But of course, a cube also has 6 faces. So each face of this cube will be 600 divided by 6. Each cube face is going to be 600 divided by 6, which of course is 100 cm squared. So if each face is 100 cm squared, we can find the length of the cube by doing the square root of 100. So the length or the height or the width is a square root of 100, which is 10 centimetres. As a double check, if this were 10 and that were 10, 10 times 10 does give 100 for one face, so it does check out to be right. So 10 centimetres is the length of this cube. But what Janet is saying is the volume of a cube is equal to the volume of a cuboid, and ultimately is she right? Well, we've done the surface area of a cuboid. We can now do the volume of a cuboid. The volume of a cube or a cuboid, you should know, is the length times width times height. So for this cuboid, it's going to be 8 times 6 times 18, which is, to be honest, I don't know. 8 times 6 times 18, 864. So that's 864 cm squared, and we can then compare that to the cube. So the volume of the cube, we've worked out the length of it now, from here was 10, so that's going to be 10 times 10 times 10, literally 10 cubed, which is 1,000. I do apologise, I've just noticed what I've done, that should say cubed, my bad. Cubed is the unit for volume, not squared. But it's saying, is the volume of a cube equal to the volume of a cuboid? Well, obviously, as you can see, no. 864 is not the same as 1,000, so you can write this fancily by saying equals not 1,000. Therefore, Janet is wrong, because these volumes are different, not the same, like she was saying. You can use incorrect if you feel a bit harsh by saying she's wrong. Either way, she is not right. Let's now move on to the next one. Question 10. Make k the subject of this formula, y equals 2m minus k. So we need to have k first. It needs to be in the form k equals, not y equals. So right now, it's where y is the subject. So k is currently being square rooted along with all of this stuff. So the first step I would suggest is we square both sides. So if we square both sides, that'll undo the square root. So y squared is, well, y squared. And if we if we square a square root, it undoes the square rooting. So we're just going to be left then with 2m minus k. We want k as a subject, so what I want in here is to have k as being a positive thing, not negative. So what I'm going to do is add k to both sides now. So on this side, we're going to have k plus y squared. Over here, minus k plus k will cancel. We'll just have 2m. And as a final step, to get k on its own, we can subtract y squared from both sides. Therefore, k is 2m minus y squared. It's written k equals, therefore k is a subject, therefore we are done. K is 2m minus y squared. Question 11, we've got some box plots about Megan's potatoes. So the box plot here shows information about the weights of her potatoes. Megan says that half of her potatoes weigh less than 50 grams each. Half is where the median is. So is she correct? Give a reason. Half would be where the median, the middle weighted potato would be, and this is on a box plot. This is the lowest value, this one here is the lower quartile, this line in the middle of the box, or somewhere between that line and that line, this represents the median. So the median is here, that's the upper quartile, that's the maximum weight. So this median is actually not on 50, that median here is actually at 57. So actually, because that's 57, she's wrong. Half of potatoes would be under 57 grams, not under 50. So 57, half are less than 57 grams, half are over. So she's wrong about it being half at being 50. Half of potatoes actually weigh less than 57 grams, because that's the median, not 50 grams. So she's wrong. Amy, however, also grows potatoes. Here's a box plot for hers. It asks us to compare the distribution of weights of Megan's potatoes with the distribution of the weights of Amy's. You need to make two comparisons of box plots. Always, always, always compare the median, which is a measure of like the average, if you like, and compare the interquartile range as well. So compare medians against interquartile ranges. So let's think about Amy. Amy's median is at 42 grams, because that's where the line was in the middle of the box. And the interquartile range is the length of the box. So from 40 to 66, this interquartile range, sorry, from 39, that one is, up to 65, my bad. Interquartile range is 65 minus 29, 39, which is 26. Over here, the interquartile range is 51 minus 35, which gives 16. So, because of that, we can say that on average, Megan's potatoes were typically heavier, because 57 is higher than 42, but because her interquartile range of weights of potatoes is greater, the range of weights for Megan's was greater. So in other words, her potatoes have less consistent weights. The smaller the IQR, the more consistent the data is. So we could say something like this. So Megan's potatoes were typically heavier than Amy's, just looking at the medians, to compare the medians against each other. But Amy's potatoes here had more consistent weights because her interquartile range was smaller than Megan's. You could have equally said, but Megan's potatoes were less consistent in their weights. Same difference. So something like this is what you need to be saying to get your marks. Question 12, we're going to have some trigonometry to do here because we've got a triangle, ABC. So, everything here is labelled. E is the midpoint of DB, angle CDB is 90 degrees, that's been given, and angle DCB, which is this one, is 40. So it's all been very nicely labelled for us. We need to work out the size of angle EAD. So angle EAD is the angle at A, the middle letter, as you move from E to D. So EAD is going to be this angle here. So I'm just going to label this in to work out in a later step. Give your answer to one decimal place, you must show all your working. We don't know anything about this triangle here, apart from the length of it's 4.4. We do know more about this one here, BDC. So let's focus on this one first, which I'm going to colour in green. So for this one, what we do know is that the angle DCB is 40 degrees. So if I just make this a bit transparent, you can see the angle there was 40 degrees. We know a side and an angle, so we can use trigonometry to work out BD. So what I'm going to do now, just get this triangle here a bit bigger, and then, because it's trigonometry, it's right angle, SOHCAHTOA. So let's label the sides. So relative to the angle we know, 40 degrees, we know this one here is opposite to this angle. So BD is the opposite side, which I'm going to just call O. The longest side, the hypotenuse, is opposite to the right angle. That's 8.6. This side here, I don't know, nor do I want to know it. So I want to know the opposite side, and I do know the H. So which of the triangles here include an O and a H? That's got an O and a H. This has a H but no O. TOA has O but no H. So we're going to use SO here. We want to work out the opposite side, so that's the one we're going to cover up. So cover up O. You can see that O must be S times by H. So for this one, the opposite side is S times H. S stands for sine of the angle we've got, so sine of 40, times by H, which is the hypotenuse, which is 8.6. And that's going to give us, let's just use a calculator for this one, sine 40 times 8.6. Really important to close a bracket there, times 8.6. That gives us 5.52797. So 5.52797. I'll put ... because I know that's not the final answer to it. It's been rounded. However, we want to work out this angle here. So focus on this triangle. We could do working out what from E to D is. Now E is a midpoint of DB, so ED will be half of the total length from D to B. So I'm going to say, therefore, DE, it'll be about 5.52, so on and so on, divided by 2. So just half that answer here, divide it by 2, 2.76398 and so on. So I'm going to label this on here. It's about 2.76398. Don't round your answer too soon, only round off at the last stage of your question. Don't round too soon, otherwise you might get some rounding error. So now what I want to do, now I've worked out some information about triangle EAD, is now I want to focus on this one here. So I've made a version of this triangle EAD over here, which we can now look at. We now know what ED is, so ED is 2.76398 and so on. I want to work out angle EAD, so I want to work out this one here. And again, we can label the sides of this triangle. So I'm going to get rid of what we labelled before, because now we're talking about a different triangle. So what sides do we know? Well, this one here, that's the opposite side, we know that one. This is the longest side, hypotenuse, I don't know that one, so I'm not bothered. This one, therefore, is the adjacent side, which I do know. So I want one of these triangles which includes the O and the A. The only triangle that includes the O and the A is TOA, so for that reason we use this triangle here. To find an angle, we're going to use T for tan. But to find an angle, we use the tan minus 1 button on a calculator. To find angles, it's either going to be sin minus 1, cos minus 1, or tan minus 1, because when the TOA triangle, we go shift tan minus 1. So cover up T, which is for tan minus 1. Then we've got O on top of A. So we do O on top of A. So that's tan minus 1. The opposite side, which is 2.76398 and so on. Your calculator will have that stored, which is nice. Divided by the adjacent, which is 4.4. So we've got that answer stored in. Just double check. There you have it. So shift tan minus 1, opposite side, which is the stored answer, divided by 4.4, close brackets, press equals, and cross your fingers. 32.1 is our answer to 1 decimal place. It doesn't round up to a 2 because next to the 1 is only a 3, so it's 32.1 degrees for our final answer. Question 13. Sakira invested £3,550 in a savings account for 3 years. She was paid 2.6% per annum, that means per year, compound interest for each of the first 2 years, and then for the third year was paid R% interest. We're told that she then had £3,819.21 in a savings account at the end of the 3 years. Work out the value of R, give answer to 1 decimal place. So, I need to remember, before anything happens to an amount, we always start with 100% of its original self. So start with 100%. What we need to do is work out the decimal multiplier. Interest, the percentage is added on to the start. So 2.6% per annum means we need to add on 2.6%. So 100% plus 2.6%. Now obviously that equals 102.6%, but on a calculator we have a percentage button. So if we do 100 shift percent plus 2.6 shift percent, we get this, which is a fraction, but press S arrow D, you should get 1.026, and that is our decimal multiplier. So that there is the decimal multiplier. Now what I mean by that is we multiply the starting amount, 3,550, by this decimal multiplier, the number of time periods the amount of money is invested for. So it's invested at 2.6% per annum. Now this 2.6% you can see here. So the second and third decimal place, that relates to the actual interest as a percentage. So the actual percentage interest rate is hidden within the decimal multiplier. Anyway, So like I was saying, we multiply 3,550 by 1.026 to the power 2 because it's at that rate for 2 years. But then she's paid a different rate for the third year. So for the third year, I'm just going to call this X. And that's only for 1 year. And then that comes out as being £3,819.21. So what we can do now, by the way, X isn't the same as R, that's why I call it a different letter. But by working out what this number X is, we can get R. So first of all, what I think we should probably do is to simplify down this bit of the calculation here into just a simpler number. So on the calculator, we can do 3,550 times by 1.026 squared, and that gives us 3736.9998. So 3736, I think it was? Yes. 0.9998 times by x to the 1, which is just an x, equals £3,819.21. Now to get x on its own, we can just divide both sides of this by this 3736.9998 number. And if we do that, we'll get what x is, where x is the decimal multiplier for r. So on the calculator, we've currently got here 3736.9998. That's what we're going to divide it by. So we do 3819.21 divided by that value. So I can just press A and S and use the calculator's storage function. And we get here 1.021998 and so on. So x equals 1.02199 and so on. So now that's the decimal multiplier. So what we can think about now is how the second and third decimal places, just like this 1.026 gave us the interest, these two decimal places, once it's been rounded, will tell us the actual percentage interest for R. So rounding it off to 3 decimal places, it becomes 1.022. And as I said, the second and third, decimal places essentially tell us the interest rate. So therefore, just like 1.026 related to 2.6%, in the same way 1.022 means 2.2%. Question 14. Sadie is going to buy a new car, and for the car she can choose one body colour, one roof colour and one wheel type. So she's got 3 different choices to make: body colour, roof and wheels. And we're told some information about how many body colours there are. There's 19 different body colours, 25 different wheel types, and what we need to do is work out the number of different roof colours that Sadie can choose from. So we're told the total number of combinations of body, roof and wheel is 3325. So that means that the number of body colours times the number of roof colours times the number of wheel types will actually multiply together to give 3325. So now all we're doing really is just substituting in these values. So body times roof times wheel has to give 3325. Now we know there's 19 different body colours. We don't know how many roof colours there are, so I'll just leave that as a question mark. And we do know the number of wheel types is 25, which equals 3325. 19 times 25, so we can do that. So on a calculator, 19 times 25, that would give you 475. So 475 lots of how many roof colours there are equals 3325. Then finally, we can just divide by 475 to work out how many roof colours there are. So therefore, number of roof colours equals 3325 divided by 475, which is 7. And that's our final answer. Question 15, we have to expand and simplify 3 brackets. So we've got 3x plus 2, 2x plus 1, and x minus 5. So different teachers might mention how to do this in different ways. My suggestion is to start at the end and work backwards. So just expand the last 2, this one and the last one, and then once you've done that, we can then deal with the very first bracket. So all we're going to do here is expand 2x plus 1, x minus 5. You can't expand 3 brackets as such, you can only do 2 brackets at a time. So we're going to do these last 2 first. 2x plus 1, x minus 5. So you should know how to do this using either FOIL or this method I prefer, which is the box method. So I've got the box here. So along the top, you write one bracket, 2x plus 1. Along the side, write the other bracket, x minus 5. So we're just going to multiply what's above each box by what's to the side of it. So this first one, we've got 2x times x, and that gives us 2x squared. This box, we've got a 1, and to the side is an x, so 1 multiplied by x is just 1x. This box is 2x multiplied by minus 5. Well, 2x times 5 would have been 10x. So 2x times minus 5 is minus 10x. In the final box, we've got 1 multiplied by minus 5. Well, 1 times 5 is 5, so 1 times minus 5 is minus 5. We then need to simplify all this down. So we've got here different things. We've got x squareds, normal x's, and just an ordinary looking number. So the x squareds, we've got 2x squareds. I've got 1x here, so I can call that 1x if I want to. 1x, take away 10 of them, gives us minus 9x's. So that's minus 9x minus 5. And so these 2 last brackets simplify to 2x squared minus 9x minus 5. So this question here can be rewritten like this, because these last 2 brackets here we've just shown are the same as 2x squared minus 9x minus 5. So what we can do now is do this first bracket multiplied by this second bracket, which just looks a bit bigger, but we can use this box method to help us. So instead of along the top us having 2 spaces for 2 different terms, now we're going to need 3 columns along the top for these 3 different things, something like this. So we're just using our answers from the first step to do the top columns like so, but the process is essentially the same. So you can pick any box in any order. I'm going to do them just as I see fit. So this box here, what's above multiplied by what's to the side? Well, 2 times 3 is 6. X squared times another x is x cubed. This one, 3 times 9 would be 27, but because it's 3 times minus 9, that's minus 27. X times x is x squared. 3x times 5 would be 15x, but because we're timesing by minus 5, minus 15x. 2x squared times 2, double 2x squareds gives us 4x squareds. 2 times 9x would be 18x, but it's a minus 9x, so minus 18x. The final box is minus 5 times 2. Well, 5 times 2 would be 10, so minus 5 times 2 is therefore minus 10. So the last step now is to just group all this together, and then we've got our final answer. So first of all, how many x cubes do we have? Well, there's just one group which has got x cubes, and there's 6 of them. So it's 6x cubed. Now we can simplify and bring together the x squared things. So we've got minus 27x squareds here, but 4 there. So either you can do minus 27 plus 4, or you can think of it as 4 subtract 27. Either way round, you should hopefully agree that it's minus 23x squared. And if in doubt, just use the calculator. 4 take 27 is minus 23. So minus 23x squared. Minus 18 minus another 15 will tell us how many x's we've got. So again, we can do that. Minus 18 minus another 15 minus 33x. And then finally the minus 10. So our final answer for expanding all three brackets is 6x cubed minus 23x squared minus 33x is minus 10. Question 16, Marek has 9 cards. There's a total of 9 cards and each card has a number. He's going to take at random 2 of the cards. He works out the product of the numbers on the 2 cards. Work out the probability that the product is an even number. Well, this word product's been mentioned twice now. Product means when you have the 2 numbers multiplied together. So the even numbers are highlighted in blue, 2, 4, 6 and 8, so obviously there's 4 even. And the odd numbers of the others, 1, 3, 5, 7 and 9. So we can see here, quite obviously, that 5 of the cards are odd and 4 are even. So just coming back to this word again in a second, product, but we're going to set up a tree diagram here. The key thing, knowing it can be a tree diagram question, is it's a probability question, and it's more than just 2 steps, because he's taking 2 of the cards. So it's a probability where more than one event happens. You might want to consider doing a tree diagram. So the first card could be odd or even, and the second card he picks could again, of course, be odd or even. But this word product, now some people doing GCSE don't know what product means. Product mathematically means one thing multiplied by the other. For example, the product of 2 and 5 is 10, it's 2 multiplied by 5. So product means when he multiplies the numbers on the 2 cards, what's the chance that that answer to the 2 card numbers being multiplied being an even? So how do you make an even number if you're multiplying 2 other numbers together? Well, if the first number's even and the second number's an even, the overall answer's an even. For example, 6 times 8 is 48, 48's even. Or an even number times an odd number, again gives an even number. For example, if I did 2 times 3, that gives me 6, that's still even. Switching these round, an odd times an even would again be an even. So in fact, the only way you'd get an odd number if you multiply 2 whole numbers together is if both are odd. So we're wanting even numbers, so we're after these first 3 scenarios only. We're not bothered about odd times odd being odd. So we're just looking at these top 3. So what we can do here is just add in these probabilities to the tree diagram. So what's the chance of the first card he picks being odd? Well, 5 cards are odd, so that'd be a 5 out of 9 chance, because 5 out of the 9 cards are odd. Whereas the chance of picking even is 4 out of 9. So let's just think about this top branch here. This top branch is a scenario where the first card he picks is an odd. So I'm going to cover up everything apart from this top branch. So let's say he's picked an odd first. The chance of him picking a second odd card after, if he picks one odd card first, then he's moved one of the 5 odd cards into his hand. So there's only another 4 to choose from. But because one odd card's already been picked, there's 1 less card in total to choose from. So picking a second odd would be 4 out of 8, which you can simplify down if you want to a half. So if you picked an odd first, that'd leave 8 cards. 4 out of 8 would be odd, and the other 4 out of 8 would have been even. Let's now think about the scenario where he picks an even card first. Well, if he picks an even card first, there's only 4 evens out of 9. So if he picks out an even, there'd only be 3 evens left out of a total of 8 next time to pick from. So the chance of picking an even second would be 3/8 if you picked an even one first. If you picked an even first, there'd still be 5 odds left. So there'd be 5 out of 8 left if you went for an odd. So now, piecing all this together, we can pick out which branches we need. So even times even is even. So we want to think of this branch here. Another branch we'd consider is even times odd. So we could have even, then odd like so. And the only other option is if it's odd and then even. These 3 scenarios only will generate an even number when they're multiplied together. So odd, then even is this route. So what we're going to do here is we multiply these values together. When we go along the branches, we multiply. So even and then even again would be 4/9 times 3/8. So for even, it's 4/9 times 3/8. Or even and odd, even and then odd would be 4/9 times 5/8. So we do that and add that on, 4/9 times 5/8. And the other scenario we're considering is if the first is odd and then it goes even. So the chance of picking an odd one first is 5/9, and then 4/8 for an even next. So 5/9 times 4/8. So the way we think about this is, we could have an even and an even, or, so we add, we could have an even and then an odd, and finally, or this third and final scenario could be odd and then even. So we're going to add these together, and what we get is going to be our overall solution to the probability of a product of these numbers is even. So, first of all, we've got 4/9 multiplied by 3/8. You can put them in brackets if you want to. It doesn't actually matter, but if it makes you feel more comfortable, please do put them in brackets. Or we could have even and then odd. So again, that's another 4/9 times 5/8. Or finally, odd and then odd again, which we said was 5/9 times 4/8. So, as long as you type it in carefully, then press equals, you'll get the solution, which is 13/18. So a 13 out of 18 chance for the product of the two numbers on his cards would be even. So the final answer, 13/18. A final word as well, if you've got an answer different to 13/18, but your answer would simplify down to 13/18, that's fine too. Question 17. Question 17. It's a circle with triangles involved. It's going to be something related to circle theorems, you can imagine. But let's just talk this through step by step. So, what do we have here? Well, quite a lot of information to digest. What sticks out to me is we're told an angle already. So angle ODA equals 32 degrees. You've got three letters in a row. It always means the angle at the middle letter as you move from the first one to the middle, then to A. So ODA means from O to D to A. So the point of the angle is there. That one's 32. So that's been given, which is quite nice of them. What else are we told? Well, it says CAD, from C to A to D, is a tangent to the circle at A. So I'm just going to highlight that in red, like so. And then we're asked to find the angle of CAB. So from C to A to B, CAB is that one there. So in blue, I'm going to highlight the angle we're wanting to find. That's our objective. So you must show all your working as well. So let's just think about what we've got here. From O to A, O is the centre of the circle, A is on the circumference. So from O to A is going to be a radius. So in blue, that line there is a radius. So we've got a radius OA hitting a tangent CAD. This is where you need to remember your circle theorems. So the radius and tangent meet at right angles, which tells us OAD, this one here is going to be 90 degrees. That's a right angle. So we can add this one on, and then because it says show all your working, say to the examiners, pick up your marks, why you know that's 90 degrees. So we know that OAD is 90 degrees because tangents meet radiuses at 90 degrees. Great. So now the next step, what could you work out next? Well, if I look at this triangle here, OAD, I know two angles, that's 90 and that's 32, so I can work out this one here next, because I know angles in a triangle add up to 180. So this one here will be 180, take away these two. So let's do that one. So 180, take away 90, take away the 32, is 58. So the next step is we can say this one here is 58 degrees. So AOD is 58 degrees, but tell the examiner and show them why it's 58 degrees by quoting the angle fact you know, which is angles in a triangle add up to 180. So even if it's obvious to you, just beat the examiner around the head of it, figuratively speaking, but you know what you're talking about to get the marks guaranteed. So what about the next step? Well, we were told here that B to O to D is a straight line. And you should know that angles on the same side of a straight line that meet at a point add up to 180 degrees. So if this bit of the straight line is 58, then on the other side, this must be 180 minus 58. So the angle BOA, we can work out by doing 180 take 58, which is 122. So then we can next say this angle here is 122. And again, give the reason. So BOA is 122. The fact we've used is angles on a straight line add to 180 degrees. Now let's look at this line from O to B. Just as from O to A was a radius, because A is on the circumference, B is on the circumference as well, so the line OB will also be a radius, so I'm going to add this in blue. So looking at the triangle BOA now, because that's a radius and that's a radius, we've got two sides of a triangle which are the same, so it's an isosceles triangle, this one. BOA is isosceles, so these two base angles here and here will also be the same. So we can work out the angle OBA, and equivalently therefore also OAB. Angles in a triangle add up to 180. 122 degrees are already taken for at this angle. So how many degrees do we have left? So 180 subtract 122 gives us 58 degrees, and that needs to be split equally between that red one and that red one, because these base angles are equal, because it's isosceles. So we then divide by 2, and we then see each one must be 29 degrees. So then we say that and give the reasoning for how we know that to be the case. So then we could say something like this, or just show the working how you got the 29 degrees. OBA is equal to angle OAB, which is 29, because base angles of an isosceles triangle are equal. Now, the final step. If that's 90 degrees on that side of A, the red and this light blue must also be 90 degrees. So now we just need to do 90 take away 29, which tells us the angle we're after, CAB, must be 61 degrees. So the final step, CAB, therefore, 90 take away 29 is 61 degrees. Just step by step by step, and be very clear with your working. Remember, no working means no marks. Question 18, we've got a histogram. So with histograms, before you even talk about the question, you need to know the formula, which will pretty much always come up if you're talking about histograms. So if ever you see a question about histograms, be thinking of this formula. Frequency density, FD, is a frequency divided by the class width. So the amount of people each bar represents, if I were to cover up the frequency with this magic hand, the frequency is the frequency density, this y-axis, multiplied by how wide each bar is. So histograms are not bar charts. The area of each bar relates to the frequency. So now we know to use this, we can actually think about the question. So it says here 20% of the trees in the park have a height between 10 meters and 12.5 meters. So between 10 and 12.5 is this little region here. So 20% of the trees are going to be represented by the bar which needs filling in here, hence the question complete the histogram. We need a final bar here which will be relating to 20% of the trees. So if 20% of the trees are missing, that must mean that these other 1, 2, 3, 4 bars must represent the other 80% of the trees. And that's our way into tackling the question. So we can work out how many 80% of the trees are, and then from that we can work out 20% here. So let's just do this bar by bar. So this first bar, how many trees are represented here? Well, between 0 and 5, that's halfway, that's going to be 2.5. So this first bar has got a class width of 2.5, and it comes up to 1.2. So 2.5 times 1.2, that's going to tell us how many trees this represents. So 2.5 times 1.2 gives us exactly 3. So this is 3 trees here. So I'll just add this in clearly. That's 3 trees. This next one is again a width of 2.5 and comes up to 2. 2.5 times 2, that's going to give us 5. This bar here is 5 wide, but this time the class width comes up to 2.5, 2.6, 2.7, 2.8. So the number of trees represented by this one will be the class width 5 times 2.8. 5 times 2.8 is 14, but do try it. As you can see, it's 14. So I'm going to put 14 here. Oops, different colour, never mind. So that's 14 trees. And this final bar, that one there's 12.5 height and goes up to 25, so that's a width of 12.5. And this class width is slightly less than 1. If you count the little squares, that's 0.8. So for this final bar, we're going to have a width of 12.5 and a height of 0.8. So 12.5 multiplied by 0.8, that gives us 10. So we've got 10 trees here in total. So 3 plus 5 plus 14 plus 10, it gives us 80% of the trees. So 80% of trees equals 3 plus 5 plus 14 plus 10. And if we just do this now quickly on the calculator, 3 plus 5 plus 14 plus 10, that comes to a total of 32 trees. So if 80% is 32, we can work out what 20% is by dividing by 4, because 80% divided by 4 tells us what 20% is. So therefore 20% of trees will be 32 divided by 4, which is 8. So in this missing bar, this needs to represent 8 trees in total. The next thing is we need to work out how high this bar needs to be that we need to draw in. So the height is the frequency density. So what we need to do for this missing bar is to calculate its frequency density. So if I take this hand and cover up FD for frequency density, we can see that the height, the frequency density of this missing bar, will be the frequency divided by the class width. So therefore, FD is a frequency, so we know now it's 8 trees in total it's representing, divided by the class width, which is 2.5. So 8 divided by 2.5 will tell us how high this bar needs to come to. 3.2. So we need to do a bar which is 3.2 high in this space here. And so what we need is something that will look a little bit like this. So we do a bar up to 3.2. That's a bit thick, that line. So 3.2. Then go along to 12.5. And then down again. The bar should look something a little bit like that. I'll straighten that line because it's going to nag me otherwise. And that's it. So the bar you're after is a bar like that. So it needs to be the correct height at 3.2. You don't need to label 3.2, but it does need to be accurately drawn. And that's all we need to do. The histogram is now complete. Question 19. We've got a hemisphere, which means half of a sphere, with diameter 8.4. Work out the volume of a hemisphere, give your answer correct to 3 significant figures. Okay, so let's imagine it was a full sphere. So for the whole sphere, we can half it after. The number of whole sphere is 4/3, just using this formula that's given, times by pi, times by the radius cubed. So what is the radius of this one? Well, the diameter's 8.4. The radius only goes halfway across. So if the diameter's 8.4, the radius will be half of that, which is 4.2. So a big stumbling block here. Remember to half the diameter to get the radius. So for the whole sphere, it would be 4/3 times pi times the radius of 4.2 cubed. So we'll do this first, and then we can half after. So 4/3 multiplied by shift pi times 4.2 cubed gives me 310.33 and so on and so on. So 310.339. So then just divide by 2 because it is a hemisphere. Hemi sounds like semi, and semi means half. So hemisphere volume will be half of this 310 number, so just simply divide by 2. See what the question wants the answer to. It wants it to 3 significant figures. So 155. That 0.1 means that 5 doesn't need to round up. So we're just going to have 155 cm cubed. So that's the answer we need to write down. Question 20, d equals 1/8 c cubed. So c has been given to 10.9, it says here, correct to 3 significant figures. So that means after it's been rounded, it came to 10.9. So first, second, third significant figure, 10.9. So if it had been lower and rounded to 3 significant figures, the next one just slightly down from 10.9 would have been 10.8. Then one down from that would be 10.7. So if you imagine a line of values which have been rounded to 3 significant figures, surrounding 10.9 on either side, it'd look like something like this. 10.7, 10.8, 10.9 is what it's closest to. Then 11.0 is the next one up, and 11.1. But it's closest to 10.9 to 3 significant figures. So it needs to be closer to this one than to 10.8 and 11.0. So it's got to be within this region here. So 10.9 has got to be within this region. So it's got to be at least halfway between 10.8 and 10.9. So the lowest boundary, the lower bound for C is 10.85, and halfway between 10.9 and 11.0 is going to be 10.95. So therefore, we know that 10.85 is the minimum C, and 10.95 is therefore the maximum value of C. This now essentially gives us a formula for calculating the minimum and max of D. So the minimum D will be when C is a minimum, and the maximum value of D will be when the value of C is at its maximum. So just modifying this formula slightly, we're going to have something like this. So the minimum D will be 1/8 times C min cubed. So we can work this out in a second, but it does say in the question, work out the value of D to a suitable degree of accuracy. So what does this mean? Well, the minimum D and maximum D aren't going to be the same values. So what we need to do is find the maximum number of significant figures we can go to where the minimum and maximum still agree with each other. So that's what we're going for. How accurate can we be where minimum and maximum D still agree? So let's work out minimum and maximum D now. So this one here, 1/8 times C min, that's going to be 1/8 times 10.85 cubed. So let's see what this gives us. So 1/8 multiplied by 10.95 cubed. Sorry, 10.85 cubed, that would have been a blunder. 159.6611. So 159.6611. Whereas the maximum value of D is where we use the value of 10.95 instead of 10.85. So if I just go back and edit my calculation, changing the 85 to a 95, might be a bit quick if you do it that way, I get 164.1165 and so on. So that's 164.1165. So clearly, they don't even agree to the nearest whole number. To the nearest whole number, that would be 160. This would be 164. So they don't agree to 3 significant figures. If I round them to 2 significant figures, though, that would round to 160, and this one would round to 160 as well. So they do at least agree to 2 significant figures, but not a third. So from here, we can therefore say that they agree to two significant figures. So therefore D is going to be 160 correct to two significant figures. If they had have agreed closer, we could have said maybe not 2 but 3, but because they only agreed to two significant figures, that's as good as we can do. Question 21, we have a speed time graph for a train journey between two stations. So if a journey took 100 seconds, so we're told that. So if we have a speed time graph, we need to know a key fact about a speed time graph, and it goes as follows. If you have a speed time graph, the area in between the graph and the x-axis tells you the distance travelled. So the area under a speed time graph relates to distance travelled. So when it says distance travelled between the two stations, we need to know that the area under speed time graph tells us that. So we need to work out the whole of this area here in red, and then we can half it to find the distance we need. So what sort of shape is this? Well, hopefully you can see here, but it's clearly a trapezium. So to work out the area of trapezium, you need to add the length of the bottom, which is 100, and the top. So add the bottom and the top, half it, and then multiply by the height. So that's 100 seconds. The top, that's 30 seconds, goes to 80. So that's going to be 50 along the top. Then the height goes from 0 meters per second all the way up to 12. So we can have these dimensions on now, and then we can calculate the full red area. So total area, in other words total distance, is going to be the whole area of this trapezium. So half, add the top to the bottom, so the bottom length is 100, the top bit's 50. We're going to multiply that by the height, which is 12, so times by 12. Then do this on a calculator, of course, because it's a calculator paper. So 1/2 of 100 plus 50 times by the 12. That gives us a total of 900. So the total distance is 900 meters. So therefore, we want the total time taken by the train to travel half the distance. So we want the total time for 400 meters. So the distance we need is 450 meters. So half the distance, that's for 450. So we need to work out the time taken to cover 450 meters. So 100 seconds covers 900. What time will get us to 450? So let's now chunk this trapezium into different bits. So this first section here is obviously a triangle. So let's be thinking, what's the distance travelled in these 30 seconds? In other words, what's the area of this triangle on the right? On the left, rather. So it's got a base of 30 seconds and a height of 12. So we can work out the area of this triangle by doing half times 30 times 12. So the area of this triangle is half times 30 times 12, which comes to 180. So this here represents 180 meters. So we need 450 in total. This first bit's 180 meters. So 450 minus 180 gives us 270. So we need here to find what area is needed, what distance to get us to 270. So if that's 180, what we'll do here, we'll say that we got that 180 by doing the full 450. We take away 180, so we need another 270 meters. So we're after trying to find what point here, there, here, somewhere along here, so that the area of this rectangle needs to be the extra 270. So how do you work out the area of a rectangle? Well, obviously it's going to be the base. We don't know this distance here, so I'm just going to call this x for a moment. So if I call this x, and the height of course is 12, So the area of this middle rectangular bit will be x times 12. So aren't the other 12 times x, that area, to be 270. So therefore x will be 270 divided by 12, which is, well, I don't know. I do know now, it's 22.5. So this bit here, we're already on 30 seconds there. So plus another 22.5 takes us to 52.5. So our x needs to be at 52.5, which is going to be somewhere like that, like so. So the total time taken is this 30 plus the x, which we worked out is 22.5. So 30 plus 22.5 equals 52.5 seconds in total. So 52.5 seconds is the answer. That gets us up to 450 meters, half of a total 900. Now the next bit we're asked here is to compare the acceleration of the train during the first part of its journey with the acceleration of the train during its last part of the journey. Well, for this bit here, for the first part of the journey, the first part relates to this gradient. Acceleration for a speed time graph is the gradient of the graph at any particular point. So for the first part, it's going up, like so. That gradient's positive, but for the last part of the journey, the gradient here will be negative. In other words, this gradient is negative. We're actually returning to probably the starting point. So we just need to make a simple comparison between this green line and that purple. You could be really complicated and actually work out the gradient and say the gradients are different, but that's going a bit above and beyond. Keep it simple is the best bet. I'd just say something like this, to be honest. The acceleration is positive, it's going up for the first bit, then for the last bit, it's negative, it's going down for the last part. Question 22, we've got some rabbits on a farm. So this question looks about 1,000,000 times harder than what it actually is. So the main formula we've got here is that the number of rabbits at the end of a month is given by P, think of that as population, n plus 1 equals 1.2 times P subscript n minus 50. Now just think about how n plus 1 relates to n. If n were 5, n plus 1 would be 6. If n were 10, n plus 1 would be 11. N plus 1 just means the next one along. But here, what the n represents is a month. So n plus 1 is the next one along. That just means the next month. So for example, if n were March, n plus 1 will be the next month, which will be April. If n were April, n plus 1 would be May, and so on. So that's all we're doing, really. So we're told here, end of March, there's 200 rabbits on the farm. So how many will there be at the end of June? So March, 200 rabbits, so we can work out what April's would be. So April, just adapting this formula here, will be 1.2 times March minus 50. So how many were there in March? Well, it's 200. So for April, that'll be 1.2 times that number in March, take away 50. So we're just going to do 1.2 times that 200, take off 50, we get 190 rabbits. So in April, there's 190. And for May, that'll be 1.2 multiplied by the month before, the April, minus 50. So just use the previous month, that 190 minus 50. So 1.2 times 190 now, take away 50. So I'm just going to alter that 200 to 190 minus 50. Got 178 rabbits, 178 of them. So end of May, 178 rabbits And finally, because we want to work out at the end of June, for June's number, you've probably guessed it, that'll be 1.2 multiplied by May's number. Again though, always with this minus 50 at the end. So 1.2 times May's number, which was 178, minus 50 gives us 163.6, which we're probably best calling just 163. So 163 rabbits, you can't have 0.6 of a rabbit. So you could interpret this either as 163 or 164 actually. I'm going to go for 163. So at the end of June, like the question asked, we've got 163 rabbits, based off using the previous month of May to get there. So 163 is our answer for how many will be at the end of June. And like I say, 164 would be accepted as well. For part B, considering your results in part A, suggest what will happen to the number of rabbits on the farm after a long time. Well, if you see here, what's happening is the number's going down each and every time. 190, 178, 163. So following this trend, it would look like eventually the number of rabbits will go to 0. Eventually they'll run out and cease to be on the farm. So we just carry this pattern on and just make a simple conclusion, something like this. So I put a red line there. Essentially, eventually there's going to be no rabbits left on the farm. Simple as that, then move on to the next question. Question 23, we've got a diagram showing a parallelogram, and then we're told the area of it is greater than 15 squared centimetres. So how do we work out the area of a parallelogram? Well, it's the same as a rectangle. The area of a parallelogram is just simply the base of it multiplied by the height. So we know the base, the length of it, it's 2x minus 1, but we don't know the perpendicular height. 10 minus x is a slant height. The perpendicular height is from this corner down to here, which I'll label on now. What we can do though is form a triangle here. So this angle was 150. If h is perpendicular, this bit of 150 degree angle here will be 90. And so this here, this tiny bit will be 60. So what I'm going to do here is think that has to be 60. That of course is 90. This angle in the corner, therefore, I'm going to use, that one will be 30 degrees. To be fair, I could use either 30 degrees or that being 60, and then use trigonometry, either using a 30 degree angle here, or saying that's 60. But essentially now what we need to do is use right angle trigonometry to find an expression for the height in terms of x, and because it's a right angle triangle, we can use SOHCAHTOA. So what I'm wanting here is to find out what h is. So relative to the angle I'm using for 30 degrees, h is the opposite side. So I'm going to highlight opposite, because I want to know the opposite. The side I do know is actually this 10 minus x side, and that's for hypotenuse. So that's for hypotenuse. I know I've used big H here, it's a bit confusing. H, little h is height, big H is hypotenuse. So I know the hypotenuse, so I'm going to shade in hypotenuse on the SOHCAHTOA triangles. I want to know the height, I do know the hypotenuse. So I want to know the opposite side, I do know h. I choose a triangle which includes both the O and the h, both what I know and what I want to know. So it's going to be the sine triangle. And I'll cover up what I want to know. So I want to work out the height, which is the opposite side. So I just cover up O for opposite here. So the height, the opposite side will be S multiplied by H. So therefore, H is going to be S times hypotenuse. So it's going to be S times hypotenuse. S stands for sine of the angle, so it's sine 30 multiplied by 10 minus x. So what's sine 30? Well, sine 30, you should, I hope, ideally know, is a half. So that's just going to be half of 10 minus x. So from that, we can then work out the area, in terms of x at least, of this parallelogram. So therefore the area is going to be half 10 minus x, which is the height. I'll do the base first. So the base is 2x minus 1 times the height, which is a half 10 minus x. So that's the area, and we're told that it's greater than 15 cm squared. So the area is greater than 15. But this here looks completely different to what we need to show that. For example, here, there's no half. So what I'm going to suggest we do here is to get rid of this half by doubling both sides. So if we times both sides by 2, and times by 2 there, then what we're going to get next is simply 2x minus 1. I'll change the colour of my pen actually. So now we're going to have 2x minus 1 brackets 10 minus x has to be bigger than 30. Still not looking like we want it to look like, but that's okay. We'll get there eventually. So what we need to do here is expand the brackets. So I'm going to do this fairly speedily. Okay, so I'm not going to show you the grid method. It's question 23. But what you should have after doing this, 2x times 10 should give you 20x. 2x times minus x is minus 2x squared. Minus 1 times 10 is minus 10. Minus 1 times minus x is plus an x, because minus multiplied by minus gives us a plus. And that gives 30. Greater than 30 rather. So now what we need to do is to be thinking what steps to use to rearrange it even further. So what we can do here is see that we can group together the x's to get 21x. So 21x, we've got minus 2x squared as well. So we've got minus 2x squared. We've got a minus 10 here. So what I'm going to do as well, I'm going to subtract 30 from both sides. So minus 10 minus another 30, that'll give us minus 40. And in terms of the normal x's, we had 20x plus an extra x. We've got 21x's. And if we take away 30 from both sides, that'll be 0 on this side. Now we're nearly there. Let's compare what we have to what we need. What we need is everything here with its sign switched. So minus 2x squared needs to become plus 2x squared. 21x becomes minus, the minus 40 becomes a plus 40, and so on. So the final step we can do is to multiply both sides by minus 1. And you need to remember, when you multiply or divide an inequality by a negative value, the direction of the inequality symbol needs to switch. But therefore, we've got it. So the minus 2x squared becomes positive 2x squared, plus 21x becomes minus 21x, minus 40 becomes plus 40, and switch the sign of this becomes this way round, which is exactly what we needed. So therefore, 2x squared minus 21x is plus 40 is less than 0 like required. Part B, find the range of possible values of x. So we're just going to take what we had from part A, which is we need 2x squared minus 21x plus 40 needs to be less than 0. So first of all, what we need to do here, we need to think about what are the critical values of x that would make it exactly equal to 0. We can then think about being less than 0 afterwards. So we're essentially solving this quadratic. So we can see if it'll factorize, or we can use a quadratic formula. It's up to you. But what you will find, using one way or the other, it will actually factorize. So using my method now, which other teachers might not have mentioned, the easier way to try and factorise a quadratic where we have more than 1x squared would be to simply multiply the n number by the 40 and then think of it as factorising x squared minus 21x plus 80 being less than 0. I'm putting that in inverted commas because it's not actually what we're solving, but we think of it like this and then factorise this like a normal one. So factorising this normally, we just need two numbers that multiply to give 80, but add together to give minus 21. So if adding two numbers together and ends up being negative, we know at least one of the numbers has to be negative. But when we multiply them together, we get a positive result. The only way we can multiply a negative by something and get a positive is if the other number is also negative. So we need two negative numbers at times to 80, add to minus 21. With a bit of thinking, you should hopefully see these numbers are minus 16 and minus 5. Now, using this method of taught my classes, that 2 disappeared in a way. You now put it back in by attempting to divide both numbers in these brackets by that number. So we try and divide the 16 by 2. We try to divide that 5 by 2. So if the number will divide, you simply divide it. 16 over 2 becomes 8. 5 over 2 won't divide or simplify, so then what we do, we simply move the 2, the bottom number, next to the x. So we have 2x minus 5. Less than 0. So now what we need to do is just think of the critical values, which would make it equal to 0. So this expression would be equal to 0 if the first bracket is equal to 0. X minus 8 is equal to 0 when x is 8. 8 take 8 is 0. So x equals 8. And also, this one here, x would be 2.5 to make this final bracket equal to 0. So x equals 5 over 2 or 2.5, whichever you want to think about. At this stage, I'm going to mention how you can use your calculator to do this for you, but you won't score marks in the test unless you back it up with working to show you know how to do it yourself. So I'm going to show you how to do this on a calculator in a moment, so bear with me. We've got the critical values, and this here, 2x squared, this is a parabola if we were to plot it. So imagine the graph. It's going to be a happy parabola. We found the critical values, which are 2.5 and 8, and this blue line is the curve. Because we want it to be less than 0, wrong colour again, sorry, we're wanting the bit of the graph which is underneath the x-axis. So you can see, therefore, it's underneath the x-axis, in between where x is 2.5 and 8. And that's the solutions we want. So therefore, we need x to be more than 2.5, but less than 8. We need it to be in between there and there. More than 2.5, but less than 8. So therefore, that's our final answer for the necessary range of x. On the calculator, we're trying to solve this inequality, aren't we? So what we do, we press menu, and you can see here on this one, there's actually no function to get it. However, there is actually a more robust version of this Casio class whiz, which I'll show you now. So this here is a GCSE friendly version of the Casio class whiz, which is absolutely fine. It's a good calculator. However, what you might want to invest in, especially if you're wanting to get the best grades and considering A-level, is this calculator. This is the higher end version of the class whiz, and this is also allowed in GCSEs. So I would strongly recommend you to consider this version of it. This one, if you press menu, you can see there's many more options. So if you were to scroll along here, there's actually a function for inequalities specifically. So press equals. Polynomial degree means what's the highest power of the inequality? Well, it's an x squared, so that's a power of 2. So press 2. then here, pick which way the symbol's going. Our symbol's facing to the right, so we need this one, which is option 2. We'll just type in exactly what it is. So how many x squared? Well, it was 2. How many x's? Minus 21. And the number on the end is 40. Press equals to enter, equals again to generate the answers. And look what we get. X needs to be in between 2.5 and 8. If that doesn't convince you to consider buying this calculator, I don't know what is. But like I say, you can't just button bash on the calculator. This is simply a check of your answer, but it's still very, very useful indeed. Question 24. A square is transformed by a combined transformation of a reflection in the line x equals minus 1, followed by a rotation. So first of all, let's just consider this. So the line x equals minus 1 is a vertical line cutting the x-axis at the point minus 1, like so. So first of all, what we could do is just simply perform that reflection. So if I label A as a black dot, B as red, C as blue, D as green, it will help us to see what the point of this question is later on. But first of all, I'm just going to reflect this. So we're going to flip this square ABCD in this dotted purple line, and we should get this. So A moves to there. That's sometimes called A dashed. The dash just means the new A. B, if you want to, you can call that B dashed, that's fine. C, that's now C dashed, and D, that's now D dashed. But to make it a bit more visual, rather than labeling the letters A, B, C, D, I'm just going to colour code so you can see where the original point and the new points are. So the next thing it's saying here is, after this rotation, under the combined transformation of reflecting it, now rotating it in a moment, 2 vertices of the square ABCD are invariant. So this barely sounds like English. In plain English, what does this mean? Well, a vertices are corners. Vertex means one corner. So it means 2 corners of a square are invariant, and invariant means do not vary, they don't change. In plain English, it just means this. 2 of the 4 corners end up back where they started. Invariant means doesn't change, so it's back to where it was. So what we're saying here, after reflecting it, then rotating it back towards here, you should find 2 of these 4 corners sort of land back on top of themselves. So the question now is to describe fully one possible rotation. So it's like, well, where do you even know how to begin here? So this rotation, describe fully one possible rotation. That's a hint that there might be more than one answer for this question. In fact, there's 4, but I'll come to this in a moment. So the key thing you need to know about rotations is the centre of rotation. It's always halfway equidistant, to be fancy. It's halfway in between the original point and the final point. So halfway in between the black and the black, you can see it'd be along this purple line somewhere. So same with the green, the blues and the reds. So what we know here is if these corners are going to get back to where they started, then what we need is the centre of rotation to be on the line of reflection. That's the only way it can happen, so these squares get back to where they were, really. These points of the square get back to where they were, I mean to say. So let's just think about this a bit deeper. So all we've been told so far is that the centre of rotation needs to be on this dotted line, but it still gives us loads and loads of possibilities. There's lots of different points we could try. The sad news is we just need to try them all. Firstly, I'm just going to give myself a bit more space. So I'm just going to move this, this grid a bit lower down so that I can have the space to actually perform these rotations so you can see what I'm doing. So first of all, let's try this very top point, which is minus 1, 6. So if we try this one here, minus 1, 6, then we put a pen, pencil or compass needle on this, we trace around this square here, and then rotate it. So let's see if we can get this back towards here. So I'm going to rotate it. I'm going to try going as well anti-clockwise. That's a quarter of a turn, that's 90 degrees. That's 180. 270. So you can see here, the black lands on the black and the blue lands on the blue. So that's where A and C are invariant. So that would actually fit the bill nicely. However, an easy way of doing a 270 degree rotation clockwise, sorry that was, would be to just go 90 degrees the other way around, like so. So then B and D don't match, but you can see A and C match. And so it could be a 90 degree anti-clockwise rotation about -1/6. That's one possible rotation we could have. So that's one possibility. If you try a different point, this point here doesn't work. But if you were to try a different point, for example, -1/4, this point would work. By the way, when I say A and C are invariant, you don't need to include which 2 points don't move. You just need to include the rotation, how many degrees it is, if it's clockwise or anti-clockwise, and the centre. You don't need to say which are invariant. I'm just doing that to add a bit more sort of description and understanding for you. Let's try rotating this one about -1/4 then. So this time, this will actually work by rotating it 180 degrees. That's 90 degrees, quarter of a turn, and 180. You can see there just about A and B land up on top of themselves. So that works. That's where A and B don't move. A and B are invariant. B and C aren't right, but that's fine, because we just want 2 of the 4 back to where they started. So therefore, we could also have a 180 degree rotation centered at -1/4, and that would mean where A and B are invariant. But we're not done yet. There's actually another 2 to find. -1/3 wouldn't work, but -1/2 does. So if we rotate now about -1/2, and again it's 180 degree rotation, I'll just get my compass out of the way slightly. That's a quarter of a turn, 180. You can see there, if you turn it half a turn, D and C are invariant if you rotate about -1 and 2. So you could have 180 degree rotation centered at -1/2, that should say. My apologies, I'll get that corrected now. There we go. And in that case, C and D wouldn't change. That just leaves us one more possibility. So the final possibility is actually at -1/0, which is down here. So -1/0, this point here. If we rotate around -1/0, like so, then what we can do here is do a 90 degree rotation in the clockwise direction. Like so. And if we do that, you can see D and B land up on top of each other. A and C don't match. So there, D and B would be invariant as required if we did a 90 degree clockwise rotation about -1/0. And that's the final one we need to include. So it's a 90 degrees clockwise rotation, centre -1/0, where B and D are invariant. So your final answer, it's one of these 4 possible options here. So a rotation at -1/6, 90 degrees anticlockwise, 180 degrees about -1/4, or 180 degrees centre -1/2, or 90 degrees clockwise centred at -1/0. And just to absolutely clarify again for the last time, you've got 4 possible answers, and you do not need to actually say what these invariant points are. You don't need to give them. So just keep it simple. What I put in brackets there isn't needed. Just give the rotation, the degrees, if it's clockwise or anti-clockwise. And the last question, question 25. We've got a straight line L with equation 3x plus 2y equals 17. And lots of information about other lines on this as well. So what we need to do here, I'd suggest, is to actually sketch this out like so. So we need a coordinate grid. So L has this equation, 3x plus 2y equals 17. Now, it's a straight line, so let's rearrange this into the best form of a straight line, which is, of course, the form y equals mx plus c. So if we take this and subtract 3x on both sides, we can see that this equation L is 2y equals minus 3x plus 17, and then dividing both sides by 2, we've got that L is y equals minus 3 over 2x plus 17 over 2, which is 8.5. So either or. So this line L has this equation here. So it's going to cross the y-axis at 17 over 2 at 8.5. It's got a gradient of minus 1.5. So it's going to be going in this sort of direction. It's going to be something like this. Okay, and that's going to be line L. So I'll label on the intercept, which is 8.5 on the y-axis. Now we can think of the next bit of information. So it says here the point A has coordinates 0, 2. So let's label this on as well. So 0, 2 is on the y-axis and it's only 2 high. So label that 2. And as well as that, it says L crosses the y-axis at the point B. So we know the point B is 8.5. So we've got that given, because we worked it out by rearranging to y equals mx plus c. We're also told about this straight line M. It's perpendicular to L and passes through A. So this line M is going to go through this point there. It's going to be perpendicular to line L as well. So it's going to look something a bit like this, where that's a right angle, and that's going to be point 2. So what we need to do here is to find where L and M intersect. Intersect at the point C, so that bit there, that's point C. So we need to find where they intersect. So we've got the equation for L, we now need an equation for straight line M. So it's perpendicular to L, it says. So because it's perpendicular to L, the gradient of M will be the negative reciprocal of the gradient of L. So we can write this in. So gradient of line M is the negative reciprocal of minus 3 over 2. So turn it on its head and switch its sign from minus to positive. So the gradient of M is 2/3. So therefore M will have the form y equals 2/3 of an x plus c, but because c is the y-axis intercept, and we know this here is 2, and we know that this line M passes through 2, c is just simply 2, so it's y equals 2/3 of an x plus 2. So we can draw this on as well. So that's M as so. So, finding where they intersect, it's where one line meets the other. So we can say now that M and L intersect when this equation here, minus 3 over 2x plus 17 over 2, is one and the same thing as this one here, 2/3 of an x plus 2. So we set one equation equal to each other. So we set L, which is this y, in terms of this here, which is the y for M, and simultaneously solve. Well, just solve the equation, I suppose. Not so much simultaneous. So what we can do here is get all the x's onto both sides. So if we add 3 over 2x's to both sides, then what we'll have is 17 over 2, 2/3 plus 3 over 2. Normally this would be a bit awkward, but with a calculator, surprisingly easy. So 2/3 plus 3 over 2. That gives 13 over 6. Got 13 over 6x plus 2. Now what we can do is subtract 2 from both sides. So if we take away 2 from here and take away 2 from there, then what we'd have would be 17 over 2 take away 2, which is, if you want to check it, it's 13 over 2. So 13 over 2 equals 13 over 6x. Then finally, to get rid of this 13 over 6, we can divide both sides by 13 over 6. So 13 over 2 divided by 13 over 6 gives us 3. So therefore, x equals 3. So I've intercept where x is equal to 3, so we can get this written in here. So C is going to be the point where x is 3. And then y is 2/3 of an x plus 2. So then we can say, and so y is 2/3 of 3 plus 2. If you do this on a calculator, you get that y is 4. So C is a point 3 and 4. But what we're wanting to do here is to work out the area of a triangle. It says here to work out the area of a triangle ABC. So we've got point C there. We said that earlier point A is where it's 0, 2 on the y-axis, and point B is, where did it say point B? Oh yeah, L crosses the y-axis at point B, so B is this point here. So A, B, C. So the triangle ABC, what we're trying to find, is the area of this here, not the area of this triangle. Okay, so what I'm going to do is just make this triangle slightly bigger so you can see what we're doing much easier. So we've got sort of this thing here. So that's 2 high, and it goes up to 8.5 high at B. So the total height from the bottom to the top must be 6.5. And as well as that, because we know the x coordinate here is 3 and the x coordinate here is 0, from this point to that point is 3 along. So we can add this in as well. We essentially know from there to there is 3. And we now know the ingredients to work out the area of ABC, because we know 6.5 is its height and 3 is its width. So we can do half times 6.5 times 3 to find the area of ABC. So therefore, area of ABC, which of course is this one here. So triangle, so it's going to be half times how high it is. So from 2 to 8.5, we've got 6.5. And from there to there is 3. So half times 6.5 times 3. Bang this into the calculator carefully. Half times 6.5 times 3. 39 over 4, which is 9.75. So you've got 9.75 units squared. And that's the final answer to the final question on the entire paper, hence we're done. So sincerely, thank you very much for watching. I hope you found that useful to some degree, hopefully very useful, but I'll take anything which is useful. Please do subscribe and leave a comment if you'd like, and I hope to see you soon to watch the next video. So once again, take care and hope to see you on the channel again soon. Ta-ra!